So this 8 is the geometric mean of this length, WX, and 10. Do you guys remember that? Yeah. So 8 equals this missing piece, which we'll label it Y, times 10, the square root. Do we remember that? Then we also need to figure out this term Z, because remember, X is the geometric mean of these two, okay? So 6 is equal to the square root of Z times 10. So what you had to do was you had to square both sides to get rid of the square root. Once you do that, you've got 6 squared, which should have given you 36, equals 10 times Z. And this one would have been 64 equals 10 times Y. Divide both sides, both times by 10. You're going to get 3.6 equals Z, and you're going to get 6.4 equals Y. So Y is going to be 6.4, and Z is going to be 3.6. You use both of those to find your geometric mean, or the altitude is going to be the geometric mean of each of those. So X is going to be equal to 3.6 times 6.4, the square root, which will give you 3.6 times 6.4, and then take the square root of that. Oops. Delete, enter. 4.8.
Yeah.
Did anyone do this problem a different way? Savannah?
I did the formula C over X equals X over B, and then
C over X equals X over B.
Yeah, so I did 10 over A equals 8 over B. XY being B, XW being B. And it goes to 10B equals 64, and B equals 6.4, and then you subtract that by 10, so A is going to equal 3.6, and then you multiply that, and you get the geometric mean of it.
Oh, okay. So you did essentially the same thing to solve for Y, right?
Yeah.
But then you just did 10 minus 6.4 to give you the other one, which is 3.6. Okay. Anyone else do it a different way? Okay, the other way you could have done this problem, okay, is you could have taken each of these triangles, right? And we know that they're all similar, right? So you could have drawn them out. So here's Y, W, Z. Write this out. W, Y, and Z. Here is W, X, Y. Okay, and then the biggest one. This looks like this. Here's our right angles. This is Y, this is X, and this is Z. Okay? And then let's go ahead and highlight all the same color, each of the sides. Is it 1111? It's 1111, people. Okay. So once we fill in all of our triangles, okay, you could have picked the biggest one and like the other medium one. Either, as long as you use the biggest one, because we know all 3 sides of the biggest one, okay? All right, let's use the black sides because those are X and 8. We'll use this as our numerator. This is our denominator. So we're going to get X over 8 equals, and then the other side that we know for both is the hypotenuse. So 6 over 10. You would cross multiply and you would get that this is 10x equals 48. Can I simplify? Oh, yeah, you could. This would become a 3. This would become a 5. So 5x equals 24. Thank you, Jaden. 5x equals 24. Divide by 5, and you're going to get x equals 24 divided by 5 should give me 4.8. And it does. Either of those two methods would help you solve 3, 4, or 5. They're all essentially the same problem, just with different numbers. Some people on their quiz set it up with the proportion. Some people did it this way, where they used the geometric mean 3 times to figure out that last final side. Yeah.
When are we gonna go over the quiz?
We'll probably go over the quiz not today, probably maybe tomorrow or on Thursday.
I swear on earth, I'm gonna throw my
Is all about the tangent ratio, okay? Now, there's 3 trigonometric ratios that we're going to learn about. Tangent is just the first one. We're taking it step by step, okay? So all we're gonna learn today is about tangent. You're gonna learn sine and cosine later, okay? But tangent's the big guy for today, okay? Now, a trigonometric ratio, okay, is formed in a right triangle, okay? It's the ratio of certain lengths of 2 sides in a right triangle. You cannot have a trig ratio if it's not a right triangle. Highlight right triangle, underline it, whatever you need to do. That is the most important part of the definition, okay? You're only dealing with trig if you've got a right triangle. It can be used to find the measure of a side or the angle in a right triangle, okay? We're going to have it do both. We're going to use tangent to find the side, and we're going to use tangent to find the angle inside these right triangles, okay? Before, if we were missing a side, we would use the Pythagorean Theorem, right? We would use the geometric mean with the altitude. We would use different ways to figure out the missing side lengths or the missing angles. Now we have a ratio that we can use, okay? And it's called tangent. All right, what is the tangent ratio, okay? So let ABC be a right triangle with an acute angle A. The tangent of A is written as tan A. And it's defined as follows. You start at the angle A. So go down to your right triangle. Guys, don't copy down anything down. Just follow with me, okay? Highlight angle A, which is this angle right here. The tangent of this angle, the tan of A, is going to be the opposite leg. So go from angle A. What is the leg that's opposite? Little a, right? Or BC. So it's going to be BC over the leg that's adjacent. So it's going to be little b.
What? Why not? Oh my god.
Or AC, okay? It's opposite over adjacent. Opposite over adjacent. Now, adjacent means next to, right? Why wouldn't we pick BA then?
Because it's a hypotenuse.
That's the hypotenuse, okay? For tangent, sine, and cosine, it will say either adjacent leg or hypotenuse. It will never say adjacent by itself. It's always the adjacent leg, okay? So if it ever says adjacent, you know it has to be a leg. It's not going to be the hypotenuse. Hypotenuse will be labeled hypotenuse, okay? Tangent does not involve the hypotenuse. We're not going to be using the hypotenuse at all with the tangent ratio. Got it? Okay. So the tangent of A is going to be little a over little b. Check it out. What would the tangent of angle B be?
Wait, oh.
So, first off, let's highlight angle B. It's going to be right over here. And it's going to be the side that's opposite, which would be what?
Little b.
Little b over little a. It's going to be the side that's opposite, which is the B, over the leg that's adjacent, which is A. What length are we not using? C. Why? It's the hypotenuse. Again, tangent does not use the hypotenuse. You guys got it? Okay. Now, this is the common misconception. We already talked about it, okay? Well, the hypotenuse, I agree, is adjacent to your acute angles, right? It is not going to be used in tangent because when we say adjacent to the angle, we mean the leg that's adjacent, not the hypotenuse. Hypotenuse, if it's going to be used, will be specified that it will be used, okay? All right, let's do some. Let's express the tangent of R as a ratio, okay? So, where is angle R? Well, it's down here. So what is the side that's opposite R? 3. And what is the side or the leg that's adjacent to R? 8. So our ratio is 3 over 8.
Do we have to simplify it or like?
Yes, if it was able to be simplified, I would expect you to simplify it. Okay? Now, what would be the tangent of S? Jaden? 8 over 3. Okay? Because here is S. Go opposite S, we've got 8. Go adjacent to S, and we've got 3. 8 over 3. Notice, if this side length down here, this SR, let's just say it was 10. Did we use 10? Why not? It's the hypotenuse. Do you guys see that? Now, sine and cosine are two other trigonometric ratios. They do use the hypotenuse. We are not learning those yet, okay? So for tangent only, we don't use the hypotenuse. Got it?
Yeah.
Okay. Let's keep going. Now, I need you to take out your calculators, okay? We are going to find the tangent of these problems, okay? So, for the first one, for A, we've got the tangent of 45 degrees. All right, I'm going to pause the video because I want to show you guys, like, on my screen what it's going to look like. Ratio, okay? So the tangent of 45 is going to be 1. Now, let's talk about what do we know about if one of our angles is 45 degrees in a right triangle.
45, 45, 90.
It's a 45, 45, 90, right? And what do we know about 45, 45, 90s?
Solve it. Isosceles.
It's isosceles. So this is going to be A. This is going to be A. What's the hypotenuse? Square root of 2 times A, right? Now, if we were to take the tangent, now hold on guys, this is really cool. If we were to take the tangent of this 45, right? The tangent of this 45 degrees, right? That would be the same as what ratio? A over A. And what's A divided by A? 1. Say, what? Do you guys see that? Is that not cool? Or do we not care? All right, so check it out. Now I want you, there's no way for us to find out the tangent of 36 degrees because it's not a special right triangle. So I need you to plug into your calculators, take the tangent, and put in 36, close your parentheses, click enter. You should get 0.72654, and we would round this to what? 0.7. Gucci? All right. Now, what if we don't know the angle, but we know the ratio, okay? This is where we use the tangent inverse, okay? So, I need you to write this down. We don't know the angle, so that's what we're looking for. So we take this number and we take the tangent -1, or the tan inverse of 2.4751, okay? So, on your calculators, type in the tangent inverse of 2.4751, close your parentheses, press enter, and you should get 68.0 degrees.
This would be when you use -1.
You don't have the tan inverse? Let me see.
Yeah, you do.
You do.
Yeah.
Just use the shift button. If you have a calculator and you cannot find the tan inverse, let me know. Did we all get this same answer when we plugged it in? No. Who didn't get it? You didn't? Okay, let me see it. Because we're rounding to the tens place. Yes, this is in degrees. Because why is this in degrees?
Because we've got the ratio.
Correct. We had the ratio. We're taking the tan inverse, okay? So we're looking for the angle that creates 2.45751, okay? How would we do D? Tan -1. Yep. Plug it into your calculator. Let's see what we get. So the tan inverse of 0.8098, close your parentheses, 39.000, so 39.0 degrees. Gucci? All right. Are we comfortable using it with our calculators? Do I have a tissue? Yeah, on my desk. Are we comfortable with like what the ratio is? It's just the side opposite over the side that's adjacent as long as they're both legs, not hypotenuse. Got it? Okay.
2/7.
I skipped one?
There's a triangle one.
Let's do some more. Let's use tangent to complete a triangle. Example 3, okay? What would the tangent of A be?
2.
Did I skip one? Is this one? All right, let's do it. What would the tangent of A be? 2/7. And we're going to make you plug it into your calculator and actually do 2 divided by 7. 2 divided by 7 is 0.2857, which rounds to 0.3.
Wait,
Oh, you want
how do you go from fraction to decimal? On the calculator?
Click the equal sign again. Uh-oh. I'll have to see yours later. Okay. Tangent of B. 7/2. Plug it into your calculator. Should get 3.5.
Is that good?
All right. The measure of angle A. Any ideas? Well, we know that the tangent of A is 2/7, right? So how would we find angle A?
Oh, you just make it the degrees. How do you, oh, you put the under.
The inverse. You have to use the tan inverse, okay? So clear your calculator, plug in tan inverse, and then put 2 divided by 7. And you should get 15.94, which is 15.9 degrees. Now, you could also do the tan inverse of 2/7, okay? I'm sorry, 7/2 to get B. Or you could just do 90 minus 15.9. Because, right, all together they have to equal 180.
Wait, how did you do that?
Okay? So that means that A was, let me write this down. A was the tan inverse of 2/7, which got us 15.9 degrees. And then tangent of B, we got was 7/2, agreed? Which we did, B is then equal to the tangent inverse of 7/2, which gave us 74.1. Now, those two added together should give me what? 90. So what is 74.1 plus 15.9? It's 90, okay? That's just a way that you can check that you did it right. That make sense? All right, questions? Yes?
How would you find this without the calculator?
You can't.
Oh, you just can't?
You cannot, no.
Like, not online?
I mean, you could.
Humanly possible to just like.
Is it humanly possible? No. I mean, not that I know of.
So like, how do they even figure this out?
So I guess I just I mixed the order of them up. Okay. Use a calculator to find the tangent. Oh, well, we're just solving for x, okay? So, what could we do?
No idea.
Let's set up a ratio.
Or I know what to do. But you can take any angle, right?
Yeah, you can take any
Alright, so
angle.
you go 35.
So the tangent of 35?
So then you
All right, so let's write that down. Tangent of 35 degrees, that's this angle, right? Is equal to what? 10 over x. Now we have an equation, we can solve it. What was another expression we could have come up with? Mariana?
55.
Tangent of 55 degrees is equal to what? X over 10. Both of these are solvable and will give you the exact same answer, okay? So let's solve the first one that Jaden came up with, okay? The first one that Jaden came up with was the tangent of 35 equals 10 over x. All right, well, let's think of this tangent of 35 as tangent of 35 over 1. Do you guys agree that we can just do that?
Yeah.
We can put anything over 1, it won't change it. And then cross multiply. So do x times tangent of 35 equals, what's 10 times 1? 10. Remember, we're solving for x, so what will we do next?
Yeah.
Divide by the tangent of 35. All right, so we've got x equals 10 divided by the tangent of 35 degrees. And we can use a calculator and plug in 10 divided by the tangent of 35 degrees. And you should get 14.28, which is 14.3.
Wait. I got 0.7.
You got 0.7? Let me see what you did. Yeah, that is the tangent of 35, but you have to do 10 divided by that. So now do 10 divided by, and then the answer button.
It just moved it back at some point.
No, you're dividing by 10. You have to do 10 divided by that. Because look, it's x is equal to 10 divided by the tangent of 35, right? You found the tangent of 35. Now you have to take that number and do 10 divided by that. Did we get 14.3? Yes? No? Maybe? All right, let's do the 55 one now, okay? Ooh. No, you don't have to do both. You can pick either one, okay? Yep. You got the 0.7 as well? Yeah, because you're only doing the tangent of 35. Yep. So, no, do 10. Plug in 10. Here, let me show you on my calculator. Okay? Tangent of 55 equals x over 10. How could we solve for x here?
Oh.
The same thing you just did on the other side.
You could kind of do it the same. What would you do?
Put 1 under.
One under here. Yeah. Cross multiply. So we're going to get x times 1, which is just x, equals tangent of 55 times what?
10
Times 10. So in your calculators, plug in the tangent of 55 and then multiply it by 10. Should get the exact same number. If you don't, let me know.
So you just have to divide and one and multiply the other.
14.3. You got it? Okay. So, did we get the same answer regardless of how we set it up? Doesn't matter how we set it up. Did we have to use tangent? Yes. Okay. All right, so now your next slide. Complete the triangle, okay? What do we use to solve this, guys? Pythagorean Theorem. A, B, and C, right? So A squared plus B squared equals C squared. Guys, why can't we use tangent here?
Because there's no other side.
We don't know either of the angles, right? And we also don't know the other leg, okay? So we do A squared plus B squared equals C squared. This would be 8 squared plus b squared equals c squared, which is 17 squared. This is going to be 64 plus b squared equals, what's 17 times 17?
289.
289. Thank you. You subtract 64 from both sides. You're going to get b squared equals 225.
B equals 15.
So b equals 15. So this last missing side is 15. Now, if we are to complete the triangle, we also need to figure out both of the acute angles, okay? So, in order to figure those out, we will need to use tangent, okay? So let's first take the tangent of A, okay? The tangent of A will be what ratio?
8 over 15.
It'll be 8 over 15. We're not going to use what? The hypotenuse at all, okay? So, we've got 8 over 15, but how do we find the actual angle?
You have to divide 8 divided by 15. Or 15
Oh.
divided by- But you have to do that first to solve
I know, but what function do we need to use?
the inverse.
The inverse, okay? So, A is going to be the tangent inverse of 8 over 15. Just remember it this way, guys. If you're looking for a side length, you're going to use the tangent. If you're looking for an angle, you're going to use the inverse, okay? So in your calculator, plug in the tangent inverse of 8 divided by 15. And you should get 28.1.
Yeah.
Does it matter if the tan is like uppercase?
No. So 28.1 degrees. Now, B, you can just take 90 and subtract it by 28.1 to give you B. Or you can actually use the tangent again. Let's use tangent again because we're practicing that. So take the tangent of B, and that's going to be equal to what?
1.9.
Tangent of B as a ratio. 15 over 8, opposite over adjacent. Your opposite side is 15, your adjacent is 8. And then we take the inverse. So we've got B equals the tangent inverse of 15 over 8. So we plug that into our calculator. The tangent inverse of 15 divided by 8. And we get 61.9. So guys, a lot of this lesson is just calculator proficiency. How good are you at using your calculator to figure this stuff out, okay? So if you're not getting these answers or you're not even attempting them on your calculator, you're doing yourself a disservice. I need you guys right now, go ahead and plug in the tangent inverse of 8 divided by 15. Make sure you get 28.1. And then plug in the tangent inverse of 15 over 8 and make sure you get 61.9. Of x to the nearest 10th. What do we do? No. We do not use the Pythagorean Theorem here. Xavier.
24 times 20.
Tangent of 24 degrees equals x over 20. You can cross multiply or you can just multiply both sides by 20. You're going to get 20 times the tangent of 24 degrees equals x. So plug it into your calculator. 20 times the tangent of 24. And you're going to get 8.9. Did we not get that?
I got 0.8.
No, because you don't want to use the calculator.
Did you multiply it by 20 though? I agree, the tangent of 24 should be like 0 point something. But then if you multiply it by 20, you should get 8.9. You didn't get that either?
No, I got it.
Oh, you got it? Okay. Huh?
You have to
Oh, how do I? Another one. Use a special right triangle to find the tangent of 60 degrees. Okay? So, let's set up a 30, 60, 90. Okay, so draw a right triangle. This will be my, oh no, that'll be my 60. This is my 30. This is my 90. Okay? We know that the side opposite the 30 is what?
30.
No, it's
No.
x squared.
A.
Oh, you did it.
The side opposite the 60 is
No.
No.
It's x squared.
A times the square root of
Oh.
3. And the hypotenuse is
Times 2. X.
2A. Yeah, I can use a different color.
Oh, I was doing.
Do you guys remember this?
Yeah.
We need to know this for our test. Okay? 30, 60,
lessons are gonna be on this test?
7.
Oh my god! What?
That's a lot.
We said they're gonna be like little.
All right. So, what we're going to do is we're going to take the tangent of 60. Remember, the tangent of 60 is going to be opposite over adjacent. What is the opposite side to the 60?
A squared.
A times the square root of 3. And what's the adjacent leg to the 60? A. Can we simplify A over A square root of 3 over A?
Yeah.
How?
You cross out A.
The A's will cancel. And we've got the tangent of 60 equals the square root of 3. Let's test it. In your calculator, I want you to take the square root of 3 and also do the tangent of 60, and they should be the same thing.
So what do you do?
Square root.
So take the tangent of 60 and then also take the square root of 3, and they should both give you 1.7320508808.
Oh yeah.
Site that makes a horizontal line. In other words, like this horizontal line will be the ground, and then your angle of elevation will be whatever angle is created looking up, okay? So it's this angle looking up, okay? So let's look at an example. You are measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height of the tree to the nearest foot. In other words, this is our angle of elevation because it's starting from the ground and it's going up. So 59 is our angle of elevation. And then we don't know the height of the tree, but we know that we're standing 45 feet from the tree. How could we figure out the height of the tree? Savannah?
You're gonna do the tangent of 59 equals h over 45, and then I put tangent 59 over 1,
Okay.
and then I did cross multiply, and then you just solve h equals tangent 59 times 45, which will give you h equals 74.9.
Good. So you do the tangent of 59 degrees. And then you multiply that by 45. And you got 74.9.
Yeah.
And it's feet.